Dajaha. Today we're going to install XPP in Windows and also in Ubuntu, and then later we consider one example, the Lorenz system. This is the timestamp if you want to jump into the example. Okay, first thing that we do is go into the official website of XPP. So since we're going to first install in Windows, so we go here, we click here. So basically there are two steps that we need to do. One is to install X11 server, and the next part is the XPP itself. Okay, first we click here and download Xming. This is where we're going to get our Xming installer and then just save it. I just click through the next buttons, and at the end I just make sure that I make a shortcut, a desktop shortcut of the Xming. So to make the Xming running, we just double click this desktop shortcut, and then here on the lower right you will see the X icon, which indicates that it is running. Okay, going on to the next step, we're going to download and install XPP. So for the installation of the XPP, there are very specific details on what to do. First, we unzip this file, and then we get the XPPAUT. It says here in the instructions that we make a copy of this XPPAUT in the C directory. And that is what we are just doing now. So we just paste it here. An additional step may be needed for Windows 8 and 10. In the XPPAUT folder, it says here that we right-click the XPPAUT.exe file and click some unlock button. So I have here my XPPAUT.exe, and it turned out that I don't have that unlock button in the security section. So I'm not sure in your case, but for my case, I don't need that. So I just leave it as it is, and it went fine. I was able to run XPP. And to use XPP, it says here that we just drag and drop an ODE file onto the XPP shortcut in the desktop. So we need to make a shortcut. And that's it, we're done with the installation of XPP in Windows 10. And now we jump into the installation of XPP in Ubuntu. So this is my system. I have this on my virtual machine, and the installation of XPP in Ubuntu is actually very quick. Just consists of two steps. So we open the terminal and then copy these two command lines here. So the first is just to update, and the installation itself, just install XPPAUT. Okay, and that means we're done. This is a new machine and I don't have any .oda file here. And that's it, we have installed XPP in Ubuntu. Quite fast. Okay, now let's jump to an example. Let's consider the Lorenz system. So I have the definition of Lorenz system here in Wikipedia, And there are actually many codes already available for you. MATLAB, you have Mathematica, Python, and etc. And now we are doing it in XPP. So we're making an ODE file out of these equations. So we open a notepad and just make our ODE file over there. So first thing that we do is to make a comment. This notation is for a comment, and we write Lorenz system. If we want to set parameter values, we just type PAR and then space and then the parameter values. Please take note that no spaces between the variables, the equal sign, and the values. And we can also initialize. For this, I just set x, y, and z all equal to 1. Again, the separation here is not comma but just spaces. So this is what makes XPP easy. You're just literally copying the equations like so. And then we can set some values for our integrator. Let's have our time step dt as 0.025 and the total time as 40. And for looking at the 3D graph, we can set the phi angle equal to 60. Then finally we just type done, telling the XPP that we're done with this file. Okay, so again, this is an ODE file, so make sure to have that .ode in the end. Okay, now to run this XPP, first we have to make sure that the xming is running already, and then drag the .ode file into the XPP shortcut like so. And we're here in XPP. So we can click on the IC and a window will show us for the initial conditions where we have set already. That means we can change the initial conditions and the parameters here. And here we can also see the time interval that we have set and the total time 40. Now we don't see any graph yet. We can simply click the go button over here. It's not so pretty, the curve goes beyond the window. And so to take care of that, we go to the window here and then click on fit, or you can just type F. So as you can see here, it looks okay now. You can also change this one into Y versus T by clicking in the X versus T portion, or you can make it Z versus the time. If you don't like the dimensions here and want to give more space, you can go to the view axis and then just set the limits here. So it says here that on the Y 40 something, we can fix that into And so to have a three-dimensional view, we go here in the view axis here, just click 3D and we just set the x-axis as x, the y-axis as y, and the z-axis as z. And also we put some corresponding labels. Now as for the limits, the height and the lows of this axis, we don't need to do that because later we can just go to the window and then fit the graph, fit the curve. So as you can see here, it's very small and we just go to the window and then fit it. So that's it. We have done a 3D graph of the Lorenz system. And that ends our tutorial for today. In our next tutorial, we're going to make null lines and vector fields. See you then. Bye-bye.